When you make a graph using systems of equations, you can see if you have one solution, you'll have intersecting lines. No solutions would be parallel lines, or infinite solutions, which would be a set of coinciding lines. When you use substitution, you can still tell how many solutions you have. You just have to know what you're looking for. First off, start by solving your problem using substitution. Make sure you have either an x equals or a y equals equation, and substitute it into the other equation that you have there. In this case, I know that x equals 3y plus 1. So I'm going to substitute that in place of x and leave the rest of my equation the same. Then I need to solve this equation. I'll start off using my distributive property, which gives me 9y plus 3 minus 5y equals 11. Now I'm going to combine my like terms. I know that 9y minus 5y is 4y plus 3 equals 11. Then I need to get my 4y all by itself, so I'm going to subtract 3 on both sides here. And that leaves me with 4y equals 8. And finally, divide both sides by 4. And I find out that my value for y equals 2. Once I know what y equals, I'm going to come back up to my original equations so that I can figure out what my value for x is. And remember, I can take either equation, but I want to take what I know for y now and substitute it in place of the value of y. So instead of x equaling 3 times y, it's going to be 3 times 2. And we know that 3 times 2 is 6, so x equals 6 plus 1, and 6 plus 1 is 7. So, based on what we know about substitution, I know that I have this ordered pair where x is 7 and y is 2. And that ordered pair is my solution. So in this case, if you get an ordered pair, you know you have one solution. And that ordered pair is the actual solution. Now, not all problems are going to work out like that. Sometimes you're going to see some other stuff. So look what happens here. Again, I know I need to start off with either an x equals or a y equals equation. So I'm going to start by moving this 2x to the other side. That'll give me y equals negative 2x plus 4. Now I'm ready to do some substitution. I can take this value for y and plug it into my other equation. So I'm going to have 6x plus 3, and then for my value of y, I'll put in my negative 2x plus 4 because that's what y equals. And then that should equal 12. So let's use our distributive property and see what happens here. I'm going to get 6x minus 6x, because 3 times negative 2 is negative 6, plus 12 equals 12. So it's time to combine my like terms. So I have 6x minus 6x. That gives me 0x. I've never had a problem where the variables canceled out like that, because 0x means I don't have any x's. That just leaves me with a statement that says 12 equals 12. Well, when you have a statement where your variables cancel out and you're left with a number sentence that's true, what this means is you have infinite solutions. Okay? So whenever you get a number sentence that's true, that means there are infinite solutions. These were a pair of coinciding lines. Now, that's not the only other situation you'll see. Watch what happens in this problem. Again, I need either an x equals or a y equals equation. So I see here x has no coefficient, so let's move this y to the other side. So I'm going to be left with x equals negative 2y plus 5. That means I'm ready. I can take this value for x and plug it into this other equation. So I'm going to have 2, and instead of x, I'm going to put in this value, negative 2y plus 5. Again, the rest of this equation stays the same, so I still have plus 4y equals 6. Now, using my distributive property, I'm going to get negative 4y plus 10 plus 4y equals 6. Okay, time to combine like terms. I have negative 4y plus 4y. Again, those y's are going to cancel out. But this time, look what's happened. I have 0y, but I'm left with a statement that says 10 equals 6. Well, this is false. Okay? When you solve a problem and you find out that your variables cancel out and the number sentence you're left with is false, that means there are no solutions to this problem. No solutions.